Hey you guys, this is Mr. Millings, and in this video we are going to apply the dilution formula that we learned in an earlier video towards the dilution of acids and bases. And it says right here that prior knowledge of the topics below is essential before watching this video. And so I recommend that you first watch the video on dilution, and then I recommend that you watch the video on calculating ion concentrations using the pH scale. So let's talk a little bit about the dilution formula and then apply that dilution formula towards the dilution of acids and bases and work a few problems out together. So let's jump right in first and start talking about the dilution formula. And so in an earlier video we talked about dilution. We said that dilution is the process of adding water or more solvent to a solution, thereby decreasing the concentration of dissolved solutes that is in that solution. And we learned a little bit about this formula right here, the dilution formula. And so we can use this dilution formula towards the dilution of acids and bases and determine the pH of those diluted solutions of acids and bases. And so it says right here that the dilution formula below can be used to perform calculations that involve determining the amount of a concentrated acid or base solution that will be needed to make a more diluted solution. Furthermore, it says also that we can use the dilution formula to determine the amount of water needed to dilute solutions, and we can use it to determine the concentrations of stock solutions and diluted solutions. So the dilution formula, or M1V1 equals M2V2, has a lot of use. We can apply it to several different types of problems, and that's what we're going to do in this video. And so if we take a look over here, M1V1 equaling M2V2, and what this formula means is that if you take the molarity of the concentrated solution and multiply it by the volume of the concentrated solution, this is going to equal the molarity of our diluted solution times the volume of our diluted solution. And so M here, or capital M, stands for the molarity of the solution in moles per liter. And when we're working with this formula, the volume units always need to be in liters as well. And so we can go ahead and start applying this formula here to several different examples. So let's go ahead and work through 4 different examples where we're going to apply this dilution formula. And let's take a look at number 1 first. And so in this problem right here, it says to find the new pH when we take 28.2 milliliters of a pH 2.60 solution, and we're going to add this to 777 milliliters of water. And so if we take a look, there's a lot going on here, but what we can see is that our starting solution has a pH of 2.60, right? And from this, we should be able to figure out M1, or the molarity of our solution, using this little diagram right here. And this is our V1, this is our volume, and we're going to have to convert this to liters. So if we take a look, M1 has a pH that is equal to 2.60. Furthermore, we know that V1 is going to be equal to 28.2 milliliters. And so now, if we take a look, we want to find the new pH of our diluted solution. And so what we should probably end up finding first is M2. If we find out the molarity, then we can easily convert this to pH using this diagram over here. And if we take a look, V2, it says that we're adding 777 milliliters to our original solution, which is 28.2 milliliters. So to get V2 here, we're going to have to take 777 milliliters and add this to 28.2 milliliters. So that's what we're looking at. So before we can start plugging these numbers in, what we have to do with these is we have to get them in the correct units. So let's go ahead and do that. Let's go ahead and start off with M1. M1, we know, has a pH equal to 2.6, but we need to get the molarity of this M1 right here. And so if we take a look, to convert the pH to a concentration, of H plus ions, we use this right here, right? We're going to use this right here to go from pH to H plus concentration. We simply take 10 to the negative pH. And so if we take 10 to the negative pH, or 10 to the negative 2.6, and we put this in our calculator, we end up with 2.51 times 10 to the negative third moles per liter, or capital M. So we have a 2.51 times 10 to the negative third molar solution of H plus ions. And so there's M1. If we take a look here, V1, we have to convert to liters. And so we're just going to slide this decimal to the left 3 times, and we have 0.0282 liters. If we take a look over here, M2 is what we're trying to find. And V2, we have 0.777 liters plus 0.0282 liters. What we did here is we slid the decimal to the left 3 times on each one of these, or divide by 1,000 to convert them to liters. And so we'll put this in our calculator. We'll take 0.777 plus 0.0282, and we end up with 0.8052. Okay, so now that we have all this information set up, we can now use this formula. So we know that M1 times V1 equals M2 times V2. And in this problem here, we're asked to solve for M2. We want to know the new molarity of our diluted solution. So that way we can then convert it to pH. So we have to divide both sides by V2. V2 is going to cancel. And the formula that we're going to use to solve this problem is M2 equaling M1 V1 all over V2. And so what is M1 in this problem? If we take a look, M1 is 2.51 times 10 to the negative third. If we take a look, what is V1? V1 is going to be 0.0282. liters, and we're going to divide this by V2. What is V2? That's right here. It's 0.8052 liters. And so when we put this in our calculator, we're going to end up with 8.88 times 10 to the negative fifth. And this is the concentration, right? This is going to be our molarity, so we'll put a capital M here. This is not our final answer though. If you look, the question wants to know the new pH of our diluted solution. So we have to carry this one final step. If you take a look here, we now know the concentration of H plus ions that are in this solution, and we now have to figure out the pH. So in order to get our pH now, we're simply going to take the negative log of our H plus concentration, and that's what we just figured out. We just figured out the H plus concentration over here was this right here. So we're going to take the negative log of 8.88 times 10 to the negative fifth, and when we put this in our calculator, we end up with a pH of 4.05. So our pH of our new solution is 4.05. Does this answer make sense? Well, if we take a look, our starting solution had a pH of 2.60. We've diluted it by adding 777 milliliters of water to this, and the pH went up. It became more basic with a pH of 4.05. Let's take a look at another example. In this example, it says how much water must be added to a 0.695 liter pH 1.28 solution to make the solution have a pH of 5.84. So if we take a look here, our starting solution or our concentrated solution is right here. Right? We're starting off with a solution that has a pH of 1.28, so it's pretty strong acid here, right? And so here is M1, here is V1. What we want to do is we want to make a solution that has a pH of this right here. And if we know the pH of this, using this diagram right here, we can figure out what M2 is going to be. So the question here is how much water must be added? Well, if we solve for V2, we can then figure out how much water must be added to this solution. So let's take a look here. We know that M1V1 equals M2V2. So the concentration, the molarity of our concentrated solution times the volume of our concentrated solution is going to equal the molarity of our diluted solution times the volume of our diluted solution. And so if we take a look here, let's put this all down here. M1, we don't know, but we do know the pH. We know the pH is equal to 1.28. And so what we can do here is we can use this little diagram right here to go from pH to H plus concentration, right? So let's go ahead and do that right now. M1 is going to equal 10 to the negative pH. So 10 to the negative 1.28. And if we put this in our calculator, we're going to end up with 5.25 times 10 to the negative 2. So here is our M1. We know M1 now. Let's take a look. If we read on, it tells us that V1 equals 0.695 liters. So we know what V1 is. If we read on, it tells us that M2 has a pH of 5.84. So our diluted solution has a pH of 5.84. We need to figure out what M2 is. We need to figure out the molarity of this. So once again, to get the pH, what we have to do is we have to take 10 to the negative pH to get our molarity. And so if we take 10 to the negative 5.84, we're going to end up with 1.45 times 10 to the negative 6th. So that is the concentration of our diluted solution. This is the concentration of H plus ions that are in our diluted solution. And so now what we now have to do is figure out what V2 is. So let's go ahead and plug all these numbers into our formula. We know that M1 times V1 equals M2 times V2. And we want to figure out what V2 is. So we're going to divide both sides by M2. M2 is going to cancel. And the formula that we're going to use to solve this problem is V2 equaling M1 times V1 all over M2. We'll plug these numbers in now. What is M1? M1 is 5.25 times 10 to the negative 2. What is V1? If we take a look, it's 0.695 liters, 0.695 liters. And what is M2 in this problem? 1.45 times 10 to the negative 6 moles per liter. So we'll put this all in our calculator and we're going to end up with 2.52 times 10 to the 4th. So this is not our final answer. The question, if you read it, is asking for how much water must be added to this. So to get this answer, we have to take this one final step further. So to get the amount of water, we have to take V2 minus V1. So V2 is right here. If we take a look, V2 is 2.52 times 10 to the 4th liters. right? So we'll go ahead and put that right here. 2.52 times 10 to the 4th liters, and we're going to subtract V1, which is 0.695 liters. We'll put this in our calculator, and we'll end up with 2.52 times 10 to the 4th liters. So since this is such a small quantity that we're subtracting from this really big number right here, we're going to end up with the same amount, essentially. All right, so how much water must be added? Looks like 2.52 times 10 to the 4th liters. Let's take a look at another example. In this example right here, it says 16.0 milliliters of a pH 4.27 solution of chloric acid is added to 611 milliliters of water. Calculate the pH of the new solution. So if you take a look here, our concentrated solution apparently is 16.0 milliliters in volume, and it has a pH of 4.27. So from this, we can extract M1 and V1. So let's do that. M1 is going to be equal to 10 to the negative pH. If you take a look, if we know the pH and we want to figure out the amount of H plus ions, we simply do this. And so the pH of this solution is 4.27, so 10 to the negative 4.27. We'll put this in our calculator, and we're going to end up with 5.37 times 10 to the negative 5th. 5.37 times 10 to the negative 5th. So that is the concentration of our H plus ions that are in this solution, right? And so now if we take a look here, what is V1? V1, it tells us is 16.0 milliliters, but we have to convert this to liters for our dilution formula here. So we'll slide the decimal to the left 3 times or divide by 1,000, and we'll end up with 0.016 liters. If we take a look over here, what we're going to end up doing is we're going to end up adding 611 milliliters to this right here. So to get V2, we have to take V1, which we know is 0.016 liters, and we're going to have to add this amount in liters. So we need to slide this decimal to the left 3 times to convert it to liters, 0.611 liters. If we put this in our calculator, 0.016 plus 0.611, we end up with 0.627 liters. So now we know V1, we know V2, and if we take a look, we're asked to calculate the pH of the new solution. So if we figure out what M2 is, if we figure out the molarity or the concentration, the new concentration of H plus ions, we can then take the negative log of that and calculate the pH. So let's go ahead and plug this all into the dilution formula. We know that M1 V1 equals M2 V2. And in this problem here, we're asked to solve for M2, so we're going to divide both sides by V2. V2 cancels. So to get the answer to this problem, we're going to have to take M2 equaling M1 times V1 all over V2. It looks like M1 we figured out to be 5.37 times 10 to the negative 5th moles per liter, times V1. V1 we figured out was 0.016 liters. And we're going to divide this by V2, which we figured out was 0.627 liters. So let's put this all in our calculator. And we end up with 1.37 times 10 to the negative 6th moles per liter of H plus ions. So this is not our final answer. What we now have to do is, now that we know the concentration of H plus ions is this right here, we can use this little diagram to go from concentration of H plus to pH of our new solution. So in our final step, let's do that. To get the pH, we simply take the negative log of our hydrogen ion concentration, which we just found out to be this right here. So we'll take the negative log of 1.37 times 10 to the negative 6th. And if we do this, we'll end up with a pH of 5.86 as our final answer. So the pH of this solution is going to end up being 5.86. So our diluted solution has a pH of 5.86, and we use 16.0 milliliters of a pH 4.27 solution of chloric acid to make this diluted solution right here. Let's take a look at one final example. In this last example, it says to calculate the H+ concentration of a solution prepared by diluting 115 milliliters of 0.262 molar barium hydroxide with enough water to make 474 milliliters of solution. So there's a lot going on here. And so if we take a look here, it looks like the volume of our concentrated solution is going to be 115 milliliters. The molarity of our concentrated solution is going to be 0.262 moles per liter of barium hydroxide. And so if we take a look, we're making a diluted solution of this volume right here. This is going to be V2. And what we're asked to figure out is we want to know the H+ concentration of this solution. So what we're going to first have to do is we're first going to have to find the hydroxide ion concentration. When we put this in water and it dissociates, it's going to produce hydroxide ions. And if we figure that out, we can then figure out the H+ concentration. So basically what we have to do here is we have to figure out the molarity of our hydroxide ion concentration. And so let's go ahead and take a look at what all the other variables are going to be. If we take a look, M1, it tells us the molarity of our barium hydroxide solution is 0.262 moles per liter. However, when we put this in water and it dissociates, it's going to produce 2 moles of hydroxide. So we have to multiply this by 2. And if we do that, we're going to end up with 0.524 moles per liter. So this is our M1 right here. If we take a look, V1, it tells us is 115 milliliters. We divide this by 1,000 or slide the decimal to the left 3 times and we'll end up with 0.115 liters. Let's continue on. M2 is what we're trying to figure out here. And V2, it tells us is 474 milliliters, which is the same thing as 0.474 liters. All right, so that's what we're looking at. And so if we solve for M2 here, we can then carry it a step further, right? We can then carry it a step further. If we figure out the OH- concentration, if we know the OH- concentration and we're asked to figure out the H+ concentration, here's what we're going to do right here, but that's our last step. So we know that M1 times V1 equals M2 times V2, and we're asked to figure out what M2 is first. So we'll divide both sides by V2. V2 is going to cancel. And the formula that we're going to use to solve this problem is M2 equaling M1 times V1 all over V2. M1 is right here, 0.524. V1 is right here, 0.115 liters. And V2 is right here, 0.474 liters. And so we'll put this in our calculator. We're going to take 0.524 times 0.115, and we're going to divide this by 0.474. And we're going to end up with 0.127 moles per liter. And this is going to equal our OH- concentration, right? Because when this dissolves, that's what we just figured out. The molarity or the concentration of OH minus ions. But the question here is not asking for the concentration of OH minus ions. The question is asking for the concentration of H+. So we know in our final step that the H+ concentration times the OH minus concentration of this solution here is going to be equal to the ion product constant 1.0 times 10 to the negative 14th. And so if we're asked to figure out the H+ concentration, we're going to divide both sides by the OH minus concentration. This is going to cancel. And the formula that we're going to use to solve this problem, it looks like we're running out of room, we'll do this right up here, is going to be the H+ concentration equaling 1.0 times 10 to the negative 14th divided by our OH minus concentration, which we just figured out was right here, 0.127, right? And we can put the unit on here if we'd like. That's not too big of a deal. And so we'll put this in our calculator. We'll take 1.0 times 10 to the negative 14th, and we're going to divide this by 0.127, and we're going to end up with 7.87 times 10 to the negative 14th moles per liter. That is going to be our H+ concentration of this solution. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that's going to subscribe to my channel. And feel free to leave any questions or comments down in the question or comment section down below. And I hope you guys found this helpful.